So let me show you, let me get the mic on. There we go. So I want to show you that. Let's turn that a little more. Okay, it's better. We're at the pool deck there, and you see the reinforcement underneath of here. You see there's the spacing, the bottom bars space pretty nicely. The bottom bars are at the bottom here, so there are bottom bars, but around this section there appears to be some mid bars also. And we come over. Okay, great. Before we do that, let's look at the this is the top slab, the slab they added to then, and then they added the red pavers on top. Okay, so there's your dimensions of concrete, about 9 inches, 9.5 approximately. This looks like a piece of rebar that was in there that was ripped out, and you can see how it's you know, it just broke cleanly, fractured. This looks like rebar, scratch marks. The rebar's here. How do we get scratch marks up there? At this point, this is kind of corrupt, this data, because of the excavator was there. But I see rebar high over here. It's high over here. I will not find an indication of that over the rest of the place. But let's look at this first. Stay with me here. Don't get ahead. The rebar is bent over here. This rebar folds back up. It comes back up to the top. Oh, what's this? Oh, it's metal. That's the sheet piling that you see. And there's the ribs of it. There's the sheet piling. There's the sheet piling. This is the stone on the other side of it. And as this was demoed, some of the stone came onto the other side of the sheet piling and gives the illusion that it's all stone in there. Reality, there was concrete there. There's the paste against it. There it is, even holding back the stone. Noteworthy, the stone acted like a gutter system. It didn't really drain out, you know, quite visually or elevation-wise, unless it had some drain underneath of it embedded at the lower end of the front of the building there. It's trapped by concrete. What I think is a nice job. It looked like a wooden deck almost when you look at it. Well, only just recently I realized that's weird. Is that concrete stamped? And it appears to be stamped concrete in the plank format. It's pretty nice, nicely done. That resolves me wondering, damn, boy, they had a lot of confidence putting that on top of that deck. I thought it was a boardwalk. My mind put the extra details in there. Remember, that's the way you would do it, and it's up to you to figure out, well, this is, you know, to run that conflict. Here's the metal here again. And right here, there's a piece of the metal right here. I'm going to outline it, and down around the stone, and around to this edge, and back again. I can't zoom in anymore for you. It looks like this is a piece of it here also. So the floor would have sat here. Now, it's going to be noteworthy. Their stone is right up to the edge of it. And that's going to be a little bit of an issue for me in a moment. There's the metal. See the metal right there, tucked inside the stone, if you will? And it would follow down, and it would follow down, and here we go. So there's the metal. My camera angle's taking a little dive, a little funky thing. But at this point, it gets kind of weird, because there's the slab. That's probably the slab elevation there somewhere. If I can go from the top of it instead, I would pick here. And this should have been, it seems like it should have gone south also. But remember, that's where that wall is there. So it's got not as much, it's got that opening there. So that would account for that to some degree. But why is it also not there, just still in place? Apparently when they poured the pad in that opening, they went around, did I'm trying to think of a word, a roundabout to get around to here. I think that's where the wall was bumped out. What I call Magellan's wall, that's bumped out, that needs attention. Or has it? Because people want to know why. It's because I knew it always needed attention. So then you see now there's the sheet piling. There's the wall on it. When we see NIST looking at it, this has all been torn. A lot of it's been torn out, and you see the sheet piling in place, showing that it goes not just a little bit down, but it's a full backer for this system presenting as. The rebar, you see the spacing of it inside the wall. You see it when NIST is showing it, along with the Army Corps of Engineers. There's a little piece of nothing there. The wall at one point had a piece of wall laying down here, but let's look down here again. Here's your sheet piling, so you see it's in place. Sheet piling, you see the layout of the rebar. Pretty nice, right? It's served its purpose. The wall didn't buckle. It's pretty stable. You don't see cracks here from all this vibration stuff they're talking about. We don't observe any cracks on this wall that aren't painted, indicating they've been there some time. I guess like a hanger. Okay, so looking at the ceiling here again, we see cross dimensions of it. Quite scary. Let me show you something here. Scary and interesting also. How you can get caught up. I mean, I could have made a video where the troll on this one, have a little fun to see if you guys catch it, but I think I'll just give it to you. I think we're pretty much done with almost all that trolling on this content. The rebar looks good. You see the way they bent it? It doesn't look like it's deformed. It didn't fracture. Rebar still had some life in it itself. Doesn't mean the connections did. Let's see if I can go back again. Okay, I'm gonna zoom out and I'm gonna click a couple of them here. Alright, so there's the chairs. I talked about it in another video. There's a chair for holding it off, the rebar off, and it's two-directional. I want to show you, let me zoom out. Hold on. Sorry that, guys. Right here, isn't that interesting? I was going to do a nice video for that and had a nice little, I did one already, playing around with it, and I decided it wasn't healthy. You know, I didn't want to play you guys like that and have a little fun and see if you could figure it out. But see the stone? Doesn't it look like the stone? It could be the same thing there, that they put stone there and then they cover it with concrete. Well, we're looking at the hot tub area, and that just presents as that presents. You know, it's pretty interesting. This is what I was looking for, actually, and I don't know if it's open in the next tab. Let's see. No, that's the crack. Let's try this tab. Nope. It didn't open up. This tab. Looking at this tab. Nope. Okay, so the wall, the fractures that you see at the south wall would be like your fractures here. Would be like the fractures here, and so it's reproducible without having to have that extra break inside the wall there. I'll get to that. Okay, that's two-directional steel. I try to lay it out and have a little dimension thing to show you, but let's see what we got here. Just let this load up, and then I'll jump back to the other tab. Okay, yeah. So there's a jealous wall with that reinforcement, and there's that gutter system he's standing on. Pretty stable. Now, I asked the engineer down there, that structural guy, to use that down there. He says, yes, it's a limestone rock. It's equivalent to our 87 stone up here, I guess, that we use a lot of. I mean, 57, sorry, 87. 57 clean. So, you see all the reinforcement, it's pretty damn consistent, and it's coming right on he's on the other side of the wall, though. It makes me wonder, you know, and it looks stretched. It's so weird. And then it broke free, I guess, because this is presented here. I was thinking when they removed the sidewalk over here, the sidewalk was up to here, I think. And when they removed it, could they have used an excavator jackhammer? It would just done damage and made its way over here and weaken this wall. That's you know, you gotta look down the rest of that wall, and I'm gonna present in this video that data that I'm saying about the excavator issue. Could they have done that? Let's go to that now. Let's go back to this one, and we'll chase over to the wall again. And as I chase over, so back one, right here. So again, these for getting your traction where we are. It's going to be pretty thick over here. There's the bottom of this wall system beyond, right here, beyond the stucco paint color look down to here. That's your first elevation here. The next elevation is the deck, the 9.5 inches, however you look at it. So then we deal with this stone here. I guess I'm not going to show you the other stone image I researched on. So you see that what happened here, this is that part where the firemen are. And that stretchy steel I mentioned, I showed, I call it stretchy, it just looks, you know, it looks like it's straining. So was it over on the others? The firemen are up here, so it's up here at this time, and you know, this is quite corrupted after they did their excavation, their demolition. And let's get that image up again, because that's that wall there. There's this wall here, transitions we're looking at, and over here we see this steel. But yet when we see now in the demo images, we get to look at this. So we don't see that steel now. So it gets everyone kind of jumpy about, there's no steel there, there's no steel there. Well, it was there. I don't know why it's not being presented to us now. You know, why did they get rid of such great data? Was it that much of a safety hazard? I would say not. So here's that end wall here. This is where the firemen are standing, and that would be here, standing right here. That's that end wall, and again, stretchy steel. And right there. So there's that wall with the stretchy steel that was that would have been there. And I'm talking again about this slab. It seems to be integral going over top of this, not at this image, but what I'm going to show you. It's like it's going over top of the steel. So here's steel here, steel. Zooming down here, right? We see the steel, see the back of the wall system? And that appears to be concrete on top of it. Not stone, but concrete on top of it. So you could have done some serious damage had you when you were moving this concrete back here at that elevation when it was a sidewalk up to here. I believe the concrete was up to there. And if you went at this with a jackhammer, you could have gotten integral into that system. So if you want to reach out to who removed that sidewalk, was it 87 Park? Did they make this weaker back here? So just so you know, I have multiple low pass failures to this deck. One of them's over there by the garage. I mean, by the parking place. That's where they did the core sample. That plane there is a beginning point. Every time I try to start, let me do a quick drape, and we'll get to this so you can see what my dilemmas are. That I'm not. So let's just show you the dilemma. So here, let's just do columns. So one, command copy. Let's do columns, right? So column, and this can be wall, right? They're pretty far apart. And these are 20 feet. These are like 27 feet. This is the wall system here. If this were to go down, so it goes out a little bit and then break, and then, well, it's cars, right? But I should, no. All right, so then, now at this point it's broken. I'm going to show you how I'll fix it in a minute with the break I'm talking about. All right, so great. So what I'll do is I'll just push this one up and push that one up. And this will be the elevation. So at this point, it's over here. As this deck goes down, so as this goes down, look what happens right here. It runs into a resistance, doesn't it? So it would create a hinge there then, if this deck to the right started going down. Well, it can't do that. But let's just look at this one in the middle. Say if it fails on one column right here, well then the unsupported span is here. It's here. All right, so it's a great span. It goes from 27 out to 47 feet from here to here if this fails. And we're talking about around it. There, it's obviously dissected. And so that would give you a more of a flexible moment. Like, so let's look at it from the bird's eye view. So if this is the 27 foot here, so I'll draw the slab for you. I'm going to draw it in sections for you, of all things. So then we'll call this the slab. The same, it's all connected. But this time I'm going to bypass it and come over here. I'm doing the same thing here. And now you see, and I'll move it over. And so these will act the same on this side. So let's put some, whoa, daddy. No, you're not being nice to me. Let's put some steel across it. So this will act that capacity across there like that. Once this punches out, these will play along with each other. But it looks like that. And then this piece would be over here also. Here's a larger piece of slab that once it's cleared, this might want to, this has unsupported span from here to the next one over, which is way offset with this. One is back there, 14 degrees off, could be as much as 56 depending where you measure it. And so it creates this torque. This part of the panel wants to go down and pull the other panel. Once it pulls that other panel, it wants to pull on the column. That's at that location. So let's see, let's just back that out. And we'll back that one out too. So as I try to work this collapse, all right, let's put this out of the way. Let's keep this profile there. Now let's just pretend like no break happened there. It just, so right. So I have to visual. You know what? I got to put a car in here. Damn it. So let's put a car in here. And then let's make another car. Some places between L and M, for example, that's straight through. There is no car there because it's a car's backed by the wall. So this, trying to start it from this end, right? A lot of people want me to start it from this end right down here. As I start, great. Oh, you know what? That works. Oh no, they don't let me pivot a shape. So I can pivot a straight line though. So as I try to shear it from this wall here, the concrete's back here. So I can't go through the wall. So what's the force that's trying to break it here? I have none. I have no force that's going to break it there. I have nothing there. Except for I could do something kind of crazy. I do have a 27-foot span. If it had top steel, the top steel would go over, say, I already did the math on that once. What was it again? 5, 6 feet? Let's call it 7 feet, and then this one's 7 feet from this side going across the top steel here. That steel exists over here above the column. Doesn't exist over here. Well, maybe it does, but I can't locate it. So this steel stops this sagging from here. You see how I can grab the middle tributary area? Because this steel, remember I don't know if the video posted yet. Imagine that was a stirrup right there. These teeth can't come apart because that stirrup keeps it from flexing more. But me, I'm trying to turn concrete upside down in the world of concrete and engineering so you guys can understand the behaviors a little more and why shear links stirrups are so critical even in a slab. Because it's really a beam. You made it a slab beam, right? Because you're loading it and everything else, and you're just using the reinforcement at the bottom there. Once it breaks, it tries to pull down from the top, and now let's double this down as a slab. Well, it's separating here. Well, wait a minute. The stirrup would help hold it together, and it'd have to pull down on the stirrup also. So these will pull down together. Not just because of the stirrup, but because, here's the drum roll, the tension in the concrete is what holds this together when you remove the stirrup. So to say concrete's weak in tension, then why does ACI allow for this? Because the only thing connecting this concrete, the bottom concrete and steel, with the top concrete and steel is the concrete between it. This going down flexural like that creates tension between between the two layers of steel. And if concrete's so weak in tension, well, then this is one of the most effective things you can do without tying the two together. It's one of the most stupidest things you can do, isn't it? Because you're saying that those two are integral to each other because they're in the concrete. It's locked in, but it's under tension. This deflects. This deflects also. But you see how this deflects differently than the top bar? Look, so well, I'm going to pull this down. I'm going to pull it down right there. Then I'm going to pull this one down. Look how its pivot point, how it changes. See how this kicked up? See how that kicked up on the corner there? The reaction of it? It went up, right? So let's do that. Let's put it back on top. There we go. And let's kick it. And then you see that we don't have that reaction there. Of course, if the concrete was there, it would change its profile. All right. So the tension is created when you get deflection. The tension wants to break away from the top bar, making the whole system even more strained as it tries to hold it without stirrups to assist it. That's George going off, Bruce going off. But I don't even know if that steel exists. The steel right here, this top piece, off it goes. Oh wow, he's going off. So I can't get this. So all right, I said I was going to do the 4. So let's come down to here. So it's 27 foot long, and for some reason, all this load here wants to try to transition into the wall, but for some reason it decides it gets out to about 21 feet and it can't do it. So the moment is over here actually that it's deflecting, and that puts strain over here that makes us want to punch out, but it also puts it against this wall. It makes it want to strain out. And that would be that crack down there, but I can't make that happen. But you could probably make it something funky happen down here. But be careful, because the rebar, if you're trying to make it disappear, no longer being functional, okay, then you do get that moment down here because it's able to release from the rebar. It's supposed to be over here in the real image right here. So it goes down. All right, so when it does that, it's got to start pulling away from this column here, because we have cars we've got to deal with down there that need to go, and it's significant. It needs to keep this up now for about there, and this needs to drop hard. Remember, the guys are going to walk through it, and it's almost going to be level down here, level down there, and then it ramps back up. So that needs to drop, and then the stress on here needs to then make this fail, and it sort of has to fail, but not right here. It's got to fail pretty much all the way out here in the middle of the parking area, the butterfly, and drop down between the two columns. I'm double dipping all these columns, so you know. And then it's flat. It's flat to it's got a little flat line or whatever right there, like that. And then it ramps back up. Too much. It ramps back up very, very slightly, and then it goes over towards past the last column, over to the building, and that's where we see the hinge point. So it's sort of like that, and there should be a car possibly under here, keeping it at rest like that, also keeping it that shape. And then if cars are here, of course this is wave ramp too much. Over here it's a lot more shallow based on the cars. So let's get rid of that. Now let's dive into the imagery again and get you through. Okay, so we'll get rid of that and don't save. So now let's go over to your left. Oops, I'm not in it. I'm going over to the left more. There we go. So remember that top part, that's all slab. That's all with this pavered, with this system here. And there's the dowels. There you can see what it presents as the back of the metal again. But this is the wall. Remember the wall system? So this sheet piling appears to be, if that sheet piling, in here right here, see it appears that the deck wraps over top of that sheet piling. Look at it over here. Right here, see how it's integral? It looks like it goes over the sheet piling, encompassing the sheet piling. So it's like 9.5 inches, let's call it, and it encompasses it. This encompasses it. This is part of that. See this is not the top rebar. This is the rebar for these things, the pavers. So don't get confused by this little bit of rebar you see there, the wire mesh, reinforcement. Over here, we see that and I've worked these scratch marks left and right. I've worked them. I'm looking for them to go parallel, horizontally, things like that. It's pretty much these scratch marks as they come down. They are all parallel. They're parallel with each other, which indicates to me that the mid span is where this happened. It didn't start from one end and sort of like zip its way down that wall. It could have, but it would create sort of an arc as it went down. I theorize that the arc would be created. I see a couple of bumps here, but this pad was not there. This pad was up here. When this failed, what we see it as, it's right about here. Looks like that's about the duplication of this to here, the 9 inches, and it might have stopped there. But remember, when we look at the top video images, we're seeing that that's this thing here, this non-structural slab leaning against the wall. We're not looking at, and we don't know where the base of it is. It could flip the other direction. There is an image from the fire department that was taken from the far end. It's too corrupt to work with. Okay, so this is the 9.5. Now it's starting to look a little smaller, but it is not. It's still the same dimensions. The slab thickness. We're going to still call it 9.5 inches. We're just getting little lens issues. That's again looks like the metal under here. It looks like it's behind there. This looks like it's way behind there. So what I'm driving as the wall, the property line of this wall, the wall and the sheet piling are not in line with each other. The wall is beyond the sheet piling. It looks like the wall plane is beyond the sheet piling. And the floor is beyond the sheet piling also. It wraps around there, and that's what they set this on. Now I was looking to see if they put a bunch of anchors in there that could have caused a problem when they placed this, causing fractures. Now their anchors are pretty spaced out. 2 here, 2 here. They're pretty spaced out. So again, I zoom in. There's a sheet piling, and it presents right here. That presents a sheet piling. The flooring appears to go over top of the sheet piling and over further. So it makes for a nice perforation in the deck to help it break free when the butterfly happens. And that would be indicated down there also. But again, that could be when they took the pad out, they could have done some damage over there, because this one's just, it happened by chance to snatch out all that concrete that was over there. I gave some credit for the weight of this encompassing it, along with being anchored down to help hold this in place. Didn't sell the anchor short. That reinforcement, this strap, if you will, if we consider the wall like a strap being held down here, and it's like a beam strap, right? And then a strap here. I only find this slight fracture here and everything. And that could have been done through, excavation, but I doubt it. It's probably the real deal. That little bump, that little pulling out right there. So again, this is the slab. I think that's the reinforcement, and I think it goes over, because the wall is there, over top of the damn sheet piling. And then they put the wall on it. So when they remove that sidewalk, this looks like it made well, like it was okay. It was made whole, if you will, because you're still seeing dimensionally 9 inches or so. So if they broke it on that side, well, we see it now. It looks great. We see it right here. It looks good also. As we get down to here, though, now it looks like a lot of that concrete is over top of the sheet piling. Unless the sheet piling is driven up there further and I'm getting my dimensions wrong, visually. But it looks like to me it looks like the sheet piling stops right about there, and this concrete is over the sheet piling. So when they were doing the deck, that they did the elevation, they corrected the elevation issues, disregarding the sheet piling as an expansion or construction joint, construction joint. It made a control joint there. But it didn't get activated over here. But over here, it appears that it's like fully activated. But it might have been activated when they were doing 87. 87, I don't know how they removed that. But that needs to be looked at elevation-wise. How did they do it? Diving back into the same wall and taking another image dive into it. my bias is that this looks like sheet piling. I don't know that to be true. This could be just happening to be the right plane and photographic, since I have a bias that it's sheet piling, that this is, I'm creating a seam that where no seam exists. But with that said, if this is metal and that's the sheet piling, you can see clearly the concrete goes over top of it, behind it, and the wall sits on top of it. There's the reinforcement, so we know where the reinforcement is roughly. This is another, this duplicated metal, if you will, in my brain. I see it here also. I also see some rust there. There's the sheet piling again, I think, into this plane here. Oh shit! Bruce scared the hell out of me when he does that stuff. He's quite vocal. So back to here again. See, that looks like sheet piling to me. We're at the end of the wall. And that looks like sheet piling. The wall system looks like it's compositely with this sheet piling. Again, that looks like sheet piling. I think I'm going to end this video short now. And you tell me what you see. If you see sheet piling, and we don't see it out here, but we can assume it was wrapped over there like that also. And then my bias is that, because it's the way I like to go at things, my bias is that, and there's the sheet piling there. It seems like that's that rib duplication, and that would be it there again here for other data. My bias is that this concrete walkway was here at one point at this elevation, because I don't think they pars the wall evenly to this block. I think it's a the wall, the sidewalk was there, and then he parged and or painted this block wall down to the top of the sidewalk. When the sidewalk was removed, here's my retraction a bit. When it was removed, we just left this exposed. Well, what am I saying then? I'm saying that they put block up to the sidewalk. Remember, they did this repair over here, and this one, what did they do? They put block up to the face of it, because this is block. I haven't been able to determine that in other imagery. This is block. So the sidewalk was here at one point. How deep did it go down? In the pad? How did the pad deal with this? Because that's rebar, and so I'm assuming that my metal sheet piling is on the other side of the rebar, obviously, other side of the sheet piling. The other side of the sheet piling. So we're looking at the sheet piling is about here now, and that's the reinforcement. I have to be careful. I was able to find something that looked like reinforcement once before, and it just turned out to be railing. This clearly is not railing, right? It presents as rebar. Just because I think, though, it could be something else that's repetitive that's, right in my mind, because I can't verify it's rebar. I only assume it's rebar. So that's something I still keep in the back of my mind. Oh, well, it's actually current. It's part of my debunk file. I keep all my conclusive files. I always have some debunk file running parallel to my conclusive files. And until all the debunk files have been removed, the conclusive file has always got a percentage. Well, they'll never get better than 99%. Always leave 1%. But it's got a percentage. And this wall system has got other conclusive files competing for it about the other location failures. So the sidewalk was up to here, I believe. Maybe the excavator guy got on there with a jackhammer excavator, which is so easy to take apart things, and he goes da 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 da, and he engages the other side, not knowing. He engages it because I just find it so convenient and suspicious that this stone was placed. If you go to 2015 Google Earth, follow the walkway, you'll be able to get up there. The first thing they did when they started on 87 Park was put a white fence up right here by chance after removing the sidewalk. First thing they did was they put the walkway in. So I don't know if that was the demand from Miami. Remember, this is Miami, not Champlain, that would be dealing with this. And so I don't know that. So then right, so they put this wall up, and instantly it stops me from being able to go up there and see more details. what I do see is that they finished this walkway here. But it also looks like the walkway's closed off. So it doesn't, they got like a scooter there in 2015. If you look it up, a go-kart, golf cart type deal. So it's not, and it looks like even a security gate right at this walkway here. So down at the street. So I was like, wow, they spent a lot of money real quick to do that. One of the last details, I'm like, what's up with that? I wondered if it was really part of their detail or their plan of attack, or was it like, oh shit, let's quickly address this, do it now, and then we'll get back to the building. So that's serious to me, this here, because this also doesn't appear, per the images, doesn't appear to come out on the street. You got stone here. You got 4 inches of stone approximately, but where's it drain? On the other side of the sheet pile, or it just fills up. It's like a gutter. Of course, it's going to drain downhill. This is about 2-3 foot up in the air from, if I can say in the air for you guys, change of elevation, slope, if you will, from the front of the building to where this man's standing. But near the front, this just stops. So let me just show you what it looks like in my visual here. So let's just bring this up. So there's the corner of let's say that's the corner of the building. Here's a sidewalk coming this way. Yeah, I'm just going to cross it over, right? There's a sidewalk. There's the street. This is all concrete. All concrete. This white stone you see down here. And there's the walkway this man standing on the walkway. So here's the walkway. The concrete looks like planks, but they're concrete stamp, I think. Okay, white stone. White stone is all here. Look where it's butting up to. Dink, dink. It goes to a concrete sidewalk. There is no presence of a surface drain here, or I looked at the sidewalk. Doesn't look like it was cut open and they ran a pipe down to a drain because they wanted pipe haters or something. It doesn't make sense to me, this stone, because it's not shallow. That stone is pretty deep for the images we saw. Don't save. All right, so this is what I'm running against in my skull. I'll erase these. I can tell you more about that another time. The other one, images show the shaft has got some data to give us. The shear wall. Yeah, I doubled down. I came back to the same location. Let me go over one. I got 2-3 of these open. Right, come back to that. That's that one. I want to keep it kind of friendly. And not that one. All right, so I think let's see if I can escape this. I think I might close it out. So this is where one of my points where it starts. Right here, because it breaks off the metal, the angle. See the angle iron? It's not even deformed, so it wasn't engaged. It just fractured off. That's why I really like this section right here. Is one of my start points. It's just no problem at all. Now, if I was going to pick, it's just bias because you see a fracture here, then you want to fill it in. And my brain does. So it says, oh yeah, when it was ripping down, it came to that side after clearing here. It had the most force, so it blasted out, and then this just easily unzipped that direction. And the deck settled down, of course. It was all, a transfer of fracture. Transfer of fracture all the way down. Transfer of fracture, I call it, is this. When you see these videos, I got a lot of videos backed up, and so you guys aren't getting, it's so much data you got to get, so you can be up to speed. But transfer fracture looks like this. So here's the bottom of concrete. Here's the top of concrete. And as you see a fracture here, depth matters more than anything, not width. The depth really matters, right? The width matters, but the depth matters more than anything, because the deeper this is, you'll get spalling up here at the top part. And that spalling is a force, is indicative of force. As this gets deeper, they get so close to each other, they finish their fracture. That's nothing. Between the two of them, they'll finish the split. This is with all your deflections. So if you see a little fine crack at the bottom, just don't measure the width and say call it a day. You need to check the depth of that, because that depth may look fine to you because it's not wide, but the fracture may be all the way through. Remember, I don't show stuff for the sport of it. The steel that I showed you, how that it was only halfway through the steel, maybe 5/8 through that piece of steel, and the rest of the steel fractured through. If you remember my steel the one I showed you, and it was a very fine crack, very fine, and yet it was complete. So this is why this matters. This depth here, telling you how far it is. Now say transfer of crack. So at one point it's just only so deep, and then it's a little bit deeper and a little bit deeper. And every time it moves, every time the crack gets deeper, let's say from here to let's say from there to here, this now creates a new. Forget this part of the slab and that part. This part creates a new capacity. The capacity's been reduced. The capacity's been reduced because it's the dimensions of the concrete are now been reduced because of the fracture. Now you're going to try to capture back in that steel, but at one point you're not going to have it anymore, and then you're just going to be able to flex that steel and create. Remember, the force multiplier of a bend has a force multiplication in it also. I think I put that video up already for you, trying to show you the pry bar effect. So that dipping also has a compressive pry bar. So they say it's compression up top is what you're taught, but the truth is it also has a force going this way. Not because of equal and opposite man, but because as it's doing that, it's trying to rip open the bottom. The two of them together are trying. Once it starts compressing down, the compression's at the top. It also wants to pull the bottom apart. So the more you have left compression wise, the deeper your crack can be. Also, it's based on PSI. Also, the low PSI, this would just bend like no champ, like nothing at all. Higher PSIs have a value in paste, not just in compressor scale, but in paste. The more paste, the better for your strength, etc. Or whatever. I didn't mean to save it. All right, so this is where my bias is over here. Right there, there's the angle irons down in here, and this is where it just ripped off. So that's that 1 foot slicks drop slab detail. You're looking at it. There's the stirrups. They did use stirrups, and the bottom steel times 2 or whatever. There's 2. There's the angle iron coming from the other side to tie into it, and the angle iron's down here that ties into it also. But it was tying at the bottom. And so that was, and it appears no top steel. Look, see no top steel across there? I'm sticking with no top steel. I don't see any there. No top steel there. This is also like that wall system. Damn it, I did not want to go this long into the video. Let's just get this over with real quick. So this drop slab detail, right? So this is the pad coming in. Square it up for me, good. Okay, there's the pad coming in. Okay, well, as this dips down, okay, so can I do that? As this dips down, there's a sag in between this deck and the next point, and it's out here's where we see that fracture from the top view. As this dips down, look, it wants to pry itself out of here. That bar that's down here in the imagery. It just wants to pry itself out of the bottom of this. There's no top steel holding it. Remember the top steel trick I showed you about? The top steel would hold these two together. But then there's no stirrups in the design. ACI still doesn't call for stirrups in this. They just resolve it through thicker slab. You got it. Well, wait a minute. Thicker slab? You're telling me now tension works? No, that's for, it's not so it doesn't punch through it. Oh, so thicker slab does that. But concrete's weak in tension still, right? Yeah. Weak in tension, 10%. Oh, okay. So then how do these two pieces of steel make love to each other without a stirrup? How do they hold each other together? Because that puts us in tension, doesn't it? Well, it gets worse than that, because I'm saying you can't have deflection. I know it's going to give you a brittle failure when it's time, but this failure didn't give him any time either. So you can't have any deflection, because if you deflect, if these don't stay parallel, which they can't, they can't. They just won't, because one's going to have a different. They're further apart. They're going to have a rotational difference. So then this one comes down and this one comes down. Look, they're not. Now we got tension here, but you have a tension on the top part of the cover wants to explode off. Down. I don't want to give away that video yet. I have a good video for that coming up. I'm ending this video before it gets too long. Hopefully you follow that. This stuff is not that easy to get across. Bye.